In this problem, we want to find the velocity and acceleration of point C. For these kind of problems, first you need to draw the kinematics diagrams of each links. Let's start with link AB. Velocity of point A is 0, acceleration of point A is also 0 because it's a fixed point. We have omega and alpha for link AB in this problem. We have a pure rotation about point A, so velocity of each point is equal to r omega, and r is the distance from the center of rotation. Here for point B it is 0.5 meter. For point B, we are moving on a circular path as the link rotates. So we have two components for acceleration. One is normal and the other one is the tangential acceleration. Please notice that the acceleration at point B, the tangential component, which is equal to r alpha, is having the directions which is consistent with the direction of the alpha. The normal acceleration also is equal to r omega square. So if you want to find the total acceleration of point B, you need to find the resultant vector. This is AB. There is another method that you can use to find the acceleration of point B, and that method is just using the relative acceleration equation, the vector analysis. Acceleration of point B is equal to acceleration of A plus alpha cross r b slash A minus omega square r b slash A. Acceleration of point A is equal to 0. It's a fixed point. So AB is equal to alpha cross r. Alpha here in this problem is equal to 6 radian per second. It's in counterclockwise direction, so if this is x and this one is y direction, alpha is in k direction. So 6k cross rb slash A. What is the position of B with respect to A? We start from A and go to the point B. So we have 0.5 cosine 45i plus 0.5 sine 45j minus omega AB square. Omega AB is 4 radian per second. So 4 square times RB slash A. 0.5 cosine 45i plus 0.5 sine 45j. Please remember that this one is a cross product, so you need to find the cross product of these unit vectors. So if you do the math, you will end up with this equation. AB is equal to minus 5.5 square root of 2 in I direction minus 2.5 square root of 2 in J direction, and the unit is meter per second square. Now we are interested to see the kinematic diagrams of link BC. So we have the velocity of B. We have acceleration for B in X and Y direction, if the link AB moves in counterclockwise direction, that gives a clockwise direction motion to link BC. So omega BC is in clockwise direction. You need to use your imagination to find the direction of omega BC. I do not have any idea about the direction of alpha BC. I'm just consider it the same as omega BC for now. And then at the end, if I end up with a negative number, I can change the direction. Also, if I have counterclockwise directions for link AB, the rotation in counterclockwise direction, then it gives a velocity to the left for point C. Point C is restricted to the horizontal motion, and when we have the counterclockwise directions for link AB, that restricted the motion of C to the left direction. The same discussions for acceleration of point C. I do not know the direction, so for now I consider it same as the velocity of point C. So this is VC and this is AC. And this angle theta is 60 degree. These are alpha BC and omega BC. I'm interested to find velocity at point C. Whenever you want to find a velocity or the angular velocity, you always can use the IC method. How we can use that method? We need to find the instantaneous center of zero velocity. So let me draw the normals to the velocities for point C and point B. This is normal to velocity, and this one is also normal to velocity at point B. This point will be my IC point in this motion. This angle is 30 degree. What we had here is that the angle that we have here is 45, and this one is also 60 degree. So that gives the other angle in this triangle as 45. This is RC/IC, and this length is RB/IC. If I want to find the velocity of point C, I need to use this equation, RC/IC times omega BC. How can I find RC/IC? You need to use the geometry equations. Let me use the sine law to find the RC/IC. So RC/IC divided by the sine of opposite angle, sine of 105, is equal to RB/IC divided by sine 30 and that is equal to 1 divided by sine 45. I use these two equations to find RB/IC. It is equal to 0.7 meter, and I use this equation and this one to find RC/IC. That is equal to 1.36 meter. So I have RC/IC in this equation, but how can I find omega BC? To find omega BC, I can use another equation. VB is also equal to RB/IC times omega BC. Do I know VB? Yes, from link AB. So let's go back to link AB. VB was R omega AB. So VB is equal to, what is R? It is 0.5 meter times omega AB, which is equal to 4 radian per second. So VB is equal to 2 meter per second. Let me plug VB, 2 meter per second. It is equal to RB/IC, it's here, 0.7 times omega BC. So omega BC is equal to 2.82 radian per second. How can I find BC? Just plug everything in this equation. 1.36 times omega BC, 2.82, it's equal to 3.84 meter per second. Now I need to find the acceleration of point C. Whenever you want to find the acceleration, you always need to use the relative acceleration vector equation. So acceleration of point C is equal to acceleration of point B plus alpha BC cross RC/B minus omega BC square times RC/B. AC is to the left direction, so we just have one component in negative I direction. So minus AC I is equal to AB from previous step minus 5.5 square root of 2 minus 2.5 square root of 2j plus alpha BC. So since alpha BC is in clockwise direction based on our initial assumption, it is in negative k direction. So minus alpha BC k cross RC/B. So this is RC/B. So minus 1 sine 60 j plus 1 cosine 60 I. And the last term is minus omega square two 2.82 square times d RC slash b minus 1 sine 60 j plus 1 cosine 60 I. So we need to compare I and j components to find the unknowns in these equations. We have two unknowns, alpha BC and also AC. If you compare these components, for the I components, we have minus AC is equal to minus a square root of 3 divided by 2 times 6.78 minus 11.77. That gives AC equal to 17.56 meter per second square. If you compare the j components, we have no j components in the left hand side of this equation, so it's 0. On the right hand side we have 3.39 minus 0.5 alpha BC. That gives alpha BC equal to 6.78 radian per second square. We see that both AC and alpha BC, they are positive numbers. That means the assumption that we made initially are the right assumptions for the direction of these two parameters.